Hi, today we will be discussing the key factors that affect water's bulk property scale of rate of evaporation, more specifically at a molecular scale that could be affecting its evaporation rate in time and temperature required to do so. Water's chemical formula is H2O, meaning a single water molecule is composed of two hydrogen atoms and one oxygen atom. As shown here, this is the Lewis structure of water, indicating that this molecule forms a polar covalent bond. As for Y covalent, this is due to oxygen being in group 6 and hydrogen in group 1, hence being both nonmetals, which is why one could call it a covalent bond. Oxygen's electronegativity is 3.5, whereas hydrogen's is 2.1, making the total difference being 1.4, which evidently is more than 0.5. Hence, this molecule is polar. In other words, this bond is seen as polar because, as seen in this model, one side is slightly more positive and the other is slightly more negative. This is indicated by the lower side containing two hydrogen atoms with weak electronegativity, and the upper side with one oxygen atom with a stronger electronegativity, as seen in the previous slide. Additionally, the reason for which this could be considered polar is because of the two pairs of free electrons that are located above the oxygen atom, right here, making the upper and lower side unequal, with the upper side attracting the electrons more strongly, hence being negatively charged, with the addition of its two pairs of free electrons, and the lower side having little attraction to its electrons due to its low electronegativity. Finally, the way evaporation rate is affected by polarity is determined by the fact that more polar molecules will stick together more and will evaporate more slowly due to their strong force of attraction, whereas less polar molecules should evaporate faster because they are not as attracted to each other. Now, this is a perfect model here because, as seen on the picture on the left, the molecule is very clearly more polar because of the atoms and molecules being far more stuck together, hence a stronger force of attraction, hence a slower rate of evaporation. Whereas the picture on the right, being a non-polar molecule, shows that the atoms are very weakly attracted to each other, hence having a weaker force of attraction and are being more apart, meaning that it would have a faster evaporation rate. Thank you.